Hey everybody, welcome back to my channel. Our next topic is types of corrosion. So there are mainly three types of corrosion. First one is differential metal corrosion. The next one is differential aeration corrosion. And the third one is stress corrosion. In this video, we'll be seeing differential metal corrosion. It's very simple. It's really very simple. So we can finish it in less than 5 minutes. So differential metal corrosion. So very simple topic you have to remember. Lesser the SRP, more the reactivity. This one thing you remember, it's sufficient. So now, what is happening in differential metal corrosion is, when we take two metals, metal A, metal B, the metal which has lesser SRP, right? The metal which has lesser SRP, suppose it has lesser SRP, this will have more reactivity. And we already know from the first chapter that the metal which has lesser SRP will act as the anode. This will act as the anode. So this will undergo corrosion and this metal will have obviously more SRP, so let's act as cathode and it will remain safe. It will not undergo corrosion. So what we are trying to do is we are trying to attach a metal with lesser SRP to a metal like this, so that this will undergo corrosion but this will remain safe. An example is, to copper boilers we attach iron handles. Copper boilers we attach iron handles. In design and selection, I'll come to it later. Okay, never mind. I won't confuse. For copper and iron SRP value is minus 0.44 volts and copper SRP value is 0.34 volts. Clearly, iron is the one which has lesser SRP, so it acts like an anode and it undergoes corrosion, whereas copper becomes cathodic and remains unaffected. One more example is of iron and zinc. It's a very popular example of galvanization if you have heard of it. Iron is attached to zinc. Galvanization, you must have heard the coating of zinc on iron, correct? That also we will be studying in the future videos under cathodic product, under corrosion prevention techniques. That also I'll tell you. So iron SRP, I just told it is minus 0.44 volts and zinc SRP minus 0.76. Now you will get confused in minus terms, it's very obvious. So which has larger positive value will be having the smaller negative value, that you have to remember. This will act as anode, this will be more reactive, this will undergo corrosion and this will prevent this from undergoing corrosion. That's why we dip the metal in molten zinc, all of that will come. So that's why zinc is acting as the anode here. It is protecting the cathode iron. So with copper, iron is acting as an anode, but with zinc it's acting as a cathode. This much only, very simple concept. So anode will undergo corrosion, cathode will remain unaffected. That's why we use alloy of iron or as handles of copper boilers, you might have observed. And this also galvanization example, coating of zinc on iron, where zinc will act as anode, undergo oxidation and undergo corrosion, so iron will remain unaffected. That was all about differential metal corrosion. Simple topic, less SRP, more reactivity. The one which has lesser SRP will act as the anode. That's it. See you in the next one. Bye bye.